Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about the metric system for the sciences. I previously made a video of the metric system for everyday use and the metric system for the trades. And in that video I talked about some of the base units in the metric system. Specifically, I talked about the base unit for length, which is the meter. Symbol for meter is small m. I talked about the base unit for capacity, which is liter. Symbol is capital L. And I talked about the base unit used for mass, which is gram, and symbol is small g. I also gave you an idea of what size each of these units were. Then I talked about the prefixes, but the only prefixes I talked about were kilo, hecto, deca, deci, centi, milli. Because typically those are the only ones you're going to see when you're talking about metric for everyday use. And the idea of the metric system is that every type of measurement has a base unit. I've only listed 3 of them here. Then there's a system of prefixes, and each of those prefixes has a set value so that when it's attached to whatever base unit you attach it to, it has the same value. So for example, if we looked at the prefix kilo, which has a value of 1000, or written as a power 10 cubed. So a kilometer is equal to 1000 meters, a kiloliter is equal to 1000 liters, and a kilogram is equal to 1000 grams. So a kilo always has the value of 1000. If all you need to know are the prefixes from kilo to milli, then my previous video shows you a very easy way of changing from one metric unit to another. It involves setting up a scale, and then however you move on the scale is exactly how you move your decimal point. In this video, we're going to get into all of the metric prefixes. So there's 20 of them in total. And I want to show you a process called dimensional analysis, which is going to allow us to change from one metric unit to any other metric unit. Let's start with the prefixes. This is my table or chart with my metric prefixes. There's 20 of them. The value of each of those prefixes and the symbol for each of those prefixes. If we look at each one specifically, iota, I put a capital letter there because the symbol is a capital Y. Has a value of 10 to the 24. So a iota meter will be 10 to the 24 meters. If I have zeta, which is a capital Z symbol, its value is 10 to the power of 21. Exa, capital E, is 10 to the power of 18. Peta, capital P, has a value of 10 to the 15. So a petaliter will be 10 to the 15 liters. Tera, capital T, 10 to the 12, and you're probably familiar with that when you've heard of terabytes. A terabyte is 10 to the power of 12 bytes. Giga has a capital G as a symbol and a value of 10 to the power of 9. Mega, 10 to the 6th, capital M. Kilo, 10 to the power of 3. From now on, my letters are small letters, so it's a small k. Hecto is 10 to the power of 2, small h. Deca, 10 to the power of 1. Its symbol is small d, small a. Then we look at the prefixes whose value is less than 1. This line represents your primary unit or your base unit, so it could be meter or liter or gram or Newton or Pascal or various other units. When we look at the prefixes less than 1, we have deci, which is 10 to the negative 1, small d. Centi, 10 to the negative 2, small c. Milli, 10 to the negative 3, small m. Micro has a value of 10 to the negative 6. Now, because we've already used a small m for milli, we use what's called the Greek letter mu for micro. So it's kind of like a funny U. Nano has a value of 10 to the negative 9 and a symbol of small n. Pico is 10 to the negative 12, small p. Femto is 10 to the negative 15, small f. Atto is 10 to the negative 18, small a. Zepto, 10 to the negative 21, small z. And yocto, 10 to the negative 24, small y. You might notice that from kilo to the top, all of these powers of 10 are multiples of 3. There's nothing in between. There's no prefix for 10 to the 4th or 10 to the 5th and so on. Similarly, from milli down, all of these powers of 10 are multiples of 3 as well, and there's nothing in between there. So you might not see these units used very often in science because they are not multiples of 3, but I want to cover all of the prefixes. When you're asked to change from one metric unit to another metric unit, I'm going to show you a process called dimensional analysis. Let's take a look. If you had a question where you were asked to change, for example, 2.4 liters to femtoliters, we look up femto and find its value. And what you have to understand is that 1 femtoliter is equal to 10 to the negative 15 liters. It's probably the biggest mistake I see students make when they're doing dimensional analysis. They put the 10 to the negative 15 with the prefix. This is telling you that femto has a value of 10 to the negative 15. So 1 femto whatever will equal 10 to the negative 15 whatever. Then what we're going to do is multiply the unit that we're changing by a fraction using these values. Because I want to eliminate liters, I'm going to put that in the denominator and put femtoliters in the numerator. I want the value of this fraction to equal 1, so I'm not changing the value. And in order to do that, these have to be equivalent. So I know that 1 femtoliter will equal 10 to the negative 15 liters. So another way that you can remember it is that the unit that has the prefix should always have the 1. The unit of measurement that's without a prefix should always have your power of 10. Now we can cancel our unit of liters, and our result will be 2.4 times 1 over 10 to the negative 15. Using our rules of exponents, if we bring that out of the denominator, we change the sign of the exponent, so it becomes 10 to the positive 15. So 2.4 liters will be equivalent to 2.4 times 10 to the 15 femtoliters. And if you think about it, that makes sense. A femtoliter is a very, very small unit, so you should have a lot of femtoliters to equal 2.4 liters. Let's take a look at some more examples. In our next example, we're asked to change 300 micrograms to grams. So we look up the value for micro, it's 10 to the negative 6. So that means that 1 microgram will equal 10 to the negative 6 grams. So when I set up my dimensional analysis, my fraction should have microgram in the denominator so that it cancels, and I want to replace it with grams. So the microgram will cancel. And remember that 1 microgram will equal 10 to the negative 6 grams. 1 with the prefix measurement and your power of 10 with your base unit. Microgram cancels, and we end up with an answer 300 times 10 to the negative 6 grams. You don't want to leave your answer in that form. If you have a power of 10, your number should be in proper scientific notation. And that means this number should be between 1 and 10. So we're going to move our decimal point 2 places so that we have a number between 1 and 10. So in other words, if we're dividing this number by 100, we should be multiplying this by 100. And in order to do that, my exponent will increase by a value of 2. So this will be 10 to the negative 4. That would be scientific notation. This is a power of 10, but that's not scientific notation because this does not fall between 1 and 10. The other option is we could write it without a power of 10. So you could write this as 0.0003 grams. You could move your decimal point 4 places to the left. Both are equivalent, and it's going to depend on what you're expected to do. In this example and in the previous example, we had a base unit, either to start with or to end with. but often you're going to be going from one prefix metric unit to another prefix metric unit. So let's take a look at how we would handle that. For example, 300 micrograms, we want to know how many milligrams that is. Now, if you want to figure out how many micrograms are in a milligram and then use that as your fraction, you certainly are welcome to do that. But I'm just going to stick with these prefixes, and I'm going to always go to the base unit first. So in this example, 300 micrograms, I'm going to change from micrograms to the base unit of grams. So I'm going to go to the unit without a prefix. Then from there, I can go to milligrams. Let's start here first. We know that 1 microgram is equivalent to 10 to the negative 6 grams. So that eliminates micrograms. But I don't want to stay in grams, I want to go to milligrams. So then my next fraction, I have grams in the numerator here, so I want to put grams in the denominator. And I want to change to milligrams. So I look up my metric prefix of milli, small m, it's equivalent to 10 to the negative 3. So I know 1 milligram is equivalent to 10 to the negative 3 grams. Now the grams will cancel, and my answer will be in milligrams. So I'll have 300 times 10 to the negative 6 divided by 10 to the negative 3 milligrams. Using my laws of exponents, if you're dividing powers with the same base, you subtract. So it'll be 10 to the negative 6 minus a negative 3, which is be negative 6 plus 3. So that will be negative 3. And again, I don't want to leave my answer like that. This is not scientific notation because this isn't between 1 and 10. So I'm going to change it to scientific notation. I'm going to move my decimal point 2 places to the left so that my number is between 1 and 10. I divided by 100, so to keep my answer equal, I have to multiply this by 100. So I add a 2 to my exponent, so that would be negative 1. So 3 micrograms will be equivalent to 3 times 10 to the negative 1 milligrams. Or you could just write this as 0.3 milligrams. So these are equivalent, and again, depending on what form you're expected to keep your answer in, choose one of those. Let's try one last example. We have 2.8 deciliters, and we want to know how many milliliters that is. So I start with 2.8 deciliters, and I want to get rid of deciliters, and I'm going to go to my base unit of liter first. So I look up deci. 1 deciliter is equivalent to 10 to the negative 1 liters. Then I cancel deciliters. I don't want to stay in liters, I want to go to milliliters. So my next fraction should have liters in the denominator so that it will cancel, and have milliliters in the numerator. I'll look up milli. Milli is 10 to the negative 3. So 1 milliliter will equal 10 to the negative 3 liters. Remember, a 1 goes with your prefix unit, and your power of 10 goes with your base unit. 1 goes with the prefix unit, your power of 10 goes with your base unit. Liters will cancel, and I'll be left with milliliters. My answer will be 10.8 times 10 to the negative 1 divided by 10 to the negative 3 milliliters. Dividing powers with the same base, I subtract my exponents. Negative 1 minus a negative 3 will be negative 1 plus 3, which will be 2. And we can leave it in that form. Or we can write it without a power of 10. Just move my decimal point to the right 2 places. So 2.8 deciliters will equal 2.8 times 10 to the 2 milliliters, or in other words, 280 milliliters. I recommend that you have this table in front of you while you're doing these conversions. I don't know if you're going to be required to memorize all these values, but if it's in front of you, it will allow you to change any metric unit to any other metric unit. In the next video, I'm going to talk about how we do the conversion if we have combined units. So practice this first, and when you're ready, I'll see you.